Hey everyone, welcome back. In this video, I'm going to show you something every cloud database engineer needs to know. How to plan ahead and protect your Amazon RDS databases when an entire AWS region goes offline. Recently, we saw a major AWS regional outage that affected multiple customers. It was a strong reminder of a simple truth in cloud architecture. Entire regions can fail. It's rare, but if you look at AWS's own historical outage summaries, it does happen. And when it does, the impact can be severe. In this video, I'm going to walk through a hands-on example of designing for regional resilience using AWS RDS backups. We'll look at how to keep your data recoverable even if your primary region becomes unavailable, what actually happens during a regional disruption, and the practical steps you need to take to avoid data loss. So let's dive in. For this demo, we'll use a very simple architecture deployed in a single AWS account. In US West 1, we have an RDS instance and two Lambda functions, all running inside a VPC. To keep the diagram clean, I'm not showing the supporting components, things like IAM role, CloudWatch event rules, subnets, and security groups, but all of that is deployed in the background. Our first step is to stand up this environment using a Terraform template that I've already prepared. So let's go ahead and deploy this now. All right, I'm in the terminal now, and I'm going to run the Terraform deployment. As you can see, the Terraform is planning to create about 15 resources. The main ones are the RDS database and the two Lambda functions. Everything else is just supporting infra like IAM and networking. I'll go ahead and run Terraform apply, and I'm going to pause the video here because it will take about 6 or 7 minutes, and I will resume the video after this is finished deploying. So it took around 6-7 minutes and the deployment completed successfully. Let me switch over to the AWS console to show you what we have. Here in the console, you can see that our Postgres RDS instance is in the available state. And we also have two Lambda functions. The first one is the scheduled Lambda, which runs every 1 minute and it inserts sample data into the database. As you can see, there's a CloudWatch event rule that's attached to this Lambda function. The second one is the view Lambda, and this is the Lambda function that we will use to view the data stored in the DB. So let me run this now, and as you can see, we have about 5 rows here, and these were inserted almost every 1 minute from the scheduled Lambda function. Next, I want to show you the current backup state of our RDS database. As you can see, there are no backups at all. There are no automated backups, no snapshot backups, literally zero backups in this region. So now we're going to use the AWS backup service, which is a centralized backup service that works not just with the RDS, but with many other AWS services. We'll use AWS backup to enable consistent policy-driven backups for this database. Inside the backup console, the first thing we need to do is we need to create a backup plan. I'll give this plan a name and create a backup rule within it. Now it's asking us to choose a backup vault. And you can think of vault as a storage container for your backups. And the big advantage here, and honestly one of the reasons companies prefer to use AWS backup over native RDS backups, is that a vault gives you custom access policies, security controls, and compliance features like backup vault, which you can't do with your traditional native AWS backups. You will also notice there is an option for a logically air-gapped vault, which is great for high compliance environments. For this demo, I'm only using a standard vault. Now, I will attach the newly created vault to our backup plan, then set the backup frequency and the backup window. Since I want the backups to start to run during this demo, I'm selecting a backup window that starts in the next couple of minutes so that the job kicks off immediately. For start within and complete within, I'm just choosing the minimum values. Now I want to pause here because this part is very important. AWS Backup supports two types of backups for databases. The first kind, continuous backups, are also called point-in-time recovery. These backups lets you restore your database to any second in the past 35 days, any second. Right? They work by creating a full backup and then continuously backing up the transactional logs. PITR replays the logs to the exact second you choose. The second kind of backups are called snapshot backups or on-demand backups, right? These backups capture the database at a specific point in time. That is the time when the backup is started. and they can be stored for up to 100 years. So continuous backups are great for precision restoration, but they can only be kept for 35 days. So if your compliance team needs retention longer than 35 days, that's where snapshots come in. For this demo, I am enabling continuous backups so we get the PITR, or the point-in-time recovery capability. Continuing with the demo, you can see here that PITR, or continuous backups, can only be retained for a maximum period of 35 days. That's the limitation from Amazon. Next, let's scroll down to the cross-region replication section, and here I'll choose my secondary region, which is US East 2. And notice here that you also have an option of copying the backups to a different AWS account altogether if you need a multi-account resiliency strategy. For this demo, we're just going to keep it to a single account. And since this is a different region where we are copying the backup to, I also need to create a vault in the US East 2 region. So I'll quickly create that and attach it here. Now notice something interesting here. Notice that you have the option of customizing the lifecycle rule for the cross-region backup. In the retention settings, you can increase the total retention from 35 days to 1 year, 10 year, or even 100 years. So why does the secondary vault can have such longer retention while the primary is limited to only 35 days with PITR? Here's the key. AWS Backup only copies snapshots or on-demand backups across regions. It does not copy the PITR data. That distinction is extremely important, and I'll show you later on in the video why. So everything looks good, and I'll just go ahead and click on the create plan and create the backup plan. Right after creating the backup plan, AWS Backup prompts us to assign resources to it. And I'll just give it this assignment a name, and I'll use the default AWS Backup Service role, which works perfectly for this demo. Next, I'll assign the specific RDS database with which we want the backup plan to protect, and that's all we need to configure here. I'll click on Assign Resources, and our backup plan is officially active. Now let's check the schedule for this backup. And okay, it's starting on November 15th, which is next day. So I might have to edit this, and so that starts right away, and I can show you guys. So let me go ahead to the backup rule, click on Edit, and update the time to start at 27 in the next couple of minutes. And click on Save, and after that, let's verify the schedule once more. Yes, now it's starting November 14th and at 1:27. And right now it's 1:25, so this should start in the next couple of minutes, and I'll pause this video and come back when the backup has finished. It's been almost 45 minutes, and as you can see, the backup job is now complete, and it started at 1:27 and it finished at 2:09. So let me switch to the vault, and so I'll go to the backup vault section and click on the vault that I just created. And as you can see, there are two recovery points. One is a snapshot backup, and the other is a continuous backup. You might wonder, why did it create a snapshot when we only enable the continuous backups? That's because cross-region copy only works with snapshots. So and the continuous backups cannot be copied across regions. So AWS Backup automatically takes a snapshot to satisfy the cross-region copy requirement. Now, if I go back to the AWS console and look at the backup settings for this database, you will now notice something different. It shows a message saying that your automated backups are now being managed by your backup plan, and you can view and manage them from the AWS Backup console. This means AWS Backup has taken ownership of how backups are stored and managed for this RDS instance. Also, from the RDS console, you can still view all the available backups. Under the automated backups, you will see the continuous PITR backups. Under snapshots, you will see all the snapshot backups. And inside the snapshot tabs, there is a category for system. These snapshots are created by the RDS service. And then there is a section for backup service. These snapshots are created by AWS Backup. So you get a clear separation of what was initiated by RDS versus what was initiated by AWS Backup. Now let's check the status of the cross-region replication. I'm in the AWS Backup console under the jobs section, and here we can see a dedicated section for copy jobs. You can see that the copy job is currently in a running state, and if I open the details, it shows that the AWS Backup is copying the snapshot from US West 1 to US East 2 region. And I'll pause the video here and come back when this job has finished. So it's been some time now, and the job has gone to the completed state. And if I click on the US East 2 vault, you can see that it contains one recovery point, and this is of type snapshot. This is the replicated snapshot of the RDS database that we originally created in the US West 1 region. Now, as we discussed earlier, continuous PITR backups are not copied cross-region by AWS Backup Service. Only snapshots are, and that's why you only see snapshot backup here. So the question is, what if you actually need PITR recovery in another region? Since AWS Backup can't do that, you will need to enable cross-region automated backup replication directly from the RDS console or the RDS service. Let's see that next. Before we keep going, let me quickly show you where we are in the demo. We started our demo with a very simple setup. We had an RDS database and two Lambda functions to interact with it. There were no backups at all. After turning on AWS Backup service, we have now a backup vault in our primary region. This backup vault contains the continuous or the PITR snapshots, as well as the snapshots or the on-demand backup, which has been copied over to the secondary vault in our US East 2 region. So at this point, we do have cross-region protection, but only for snapshots or on-demand type of backups. The continuous PITR backups are still stuck in the primary region. So the natural next question is, how do we get PITR replication across regions? And the answer is, you can only do this via the AWS RDS service. You cannot use the AWS backup service for it. And let me show you how that works. All right, I'm back in the AWS console now. I'm going to open up my RDS database in the primary region and click on Modify. If I scroll down to the backup section, which should be right here, we see something interesting. It says the backups are being managed by the backup plan, which we already knew. But there isn't much to change here except for this thing around backup replication. Now, AWS doesn't explicitly say whether this copies PITR or snapshots, but if you read the description, it mentions transaction logs, which means this is for PITR. So I'll enable the cross-region automated backups, pick my destination region as US East 2, and leave the retention settings as default, and hit Modify. Now to check whether replication has started, I switch over to the secondary region, and which is the US East 2 region. And within automated backups, there is a tab called replicated. When I click that, I can see that PITR backups have started coming in from the primary region. Right now, the status says pending, so it takes a little bit of time, but you can clearly see the source region listed here as US West 1. So in our updated architecture, we now have our continuous backups being replicated by the RDS service. But remember, these continuous replicated backups do not live inside the backup vault. They are outside the vault. That means they don't get any of the vault level protections that you get when you use the AWS backup service. So no air-gapped vault, no vault lock, no custom access policies. These controls, these specific security compliance controls, only apply to snapshot backups stored inside the backup vault. So from a disaster recovery perspective, if our primary RDS database goes down in case of a disaster, we now have two different restore options. One is the snapshot backup, which is stored in the backup vault with compliance and security controls. And second is the PITR or continuous backups, which have a much lower RPO, but they don't have the vault protections. So now let's go ahead and simulate a regional disaster. I will go ahead and temporarily stop our RDS database, and then we'll test both of these restore paths to see how they behave. Okay, so before I stop the primary DB, let's quickly capture what the database currently contains so we can compare it after the restore. I'm going to run my view lambda again, and here you can see that we have row 86 here, right? And the last data that it was entered as was around 235, 235 on November 14th. So I'll take a screenshot of this, and now I will go back to the RDS database and simulate our disaster by temporarily stopping the stop temporarily button, and I will temporarily stop this DB. And this takes some time, so I'll pause the video here and come back when this has stopped. All right, it's been some time and the DB is now stopped. If I view the Lambda again, you'll see it fails, which is exactly what we expected. So the primary region or the primary DB is effectively down, and we'll note the disaster time as 2:39 p.m. PST, November 14th. Okay, so now that the DB is down, I'll switch over to the secondary region so we can restore the database there. And this is my green terminal, just so we can differentiate between the two. And I'm going to deploy the exact same Terraform code as we deployed earlier. The only difference here is that I'm now going to provide a region here, which is the US East 2. And if you see from my Terraform code, this is the variable that I'm providing in the AWS provider here. And the second difference in this code is that I'm going to supply a new variable for the restore point. And because this new database would not be created from scratch, it will be restored from a backup. So this is the restore from snapshot variable. And you can see in the code, this is what we are supplying to the RDS database Terraform resource. So, and to get to the value for this restore point, we'll go to our Ohio region or the second region, and we'll select the recovery point ID from the backup vault. So note here that this is not the PITR backup, this is the snapshot backup ID. And so with that done, I'm going to run this code, um, run the Terraform apply. I have to do the Terraform init here again, since this is a new directory. And so now after this, I can run the Terraform apply, and this will take some time. But what we're doing effectively here is that we are creating the exact same architecture as before in a new region, but with the RDS created from a restore point instead of an empty state. So I'll pause the video and come back to it when this is finished deploying. So the Terraform apply has completed successfully. All 15 resources have been created. Let me switch over to the AWS console in the secondary region and verify everything. You can see that the RDS instance is in the available state, and also both of our Lambda functions, the insert function as well as the view function, have also been created. Now let's check the restore database and see what it actually contains. So I'll run the view Lambda function, and you can immediately see that this now will have lesser number of rows compared to our primary database. And let me switch over, let me take a screenshot of this, and I'll switch over to our architecture diagram to tell you why this has happened. We deployed a new RDS instance in the secondary region using option number 1, which is the snapshot based backup. And because the snapshot was taken at a specific point in time, any data that was written after the snapshot was simply not available. And from the screenshots, you can clearly see what happened. Before disaster, we had about 86 rows, and the most recent timestamp was 2:35 p.m. And after recovering from the snapshot, the most recent record we have for region 1 sample data is with a timestamp of 1:51 p.m. So we lost roughly 45 minutes of data, and that's expected because snapshot backups are static. They don't continuously capture changes. So let's move on to our final segment of the video. And this time we would be using option 2 to restore this database following the same recovery process. And you can see how clearly, you can see clearly how different these two approaches are. And this time we'll be restoring the DB using the continuous PITR snapshots. Back in the terminal, I'm going to run the updated Terraform apply command. And this time I'll be passing in the variable restore to point in time. In the Terraform code, this corresponds to the configuration block inside the RDS database that restores the database using the point-in-time recovery. So this is different from what we did earlier with the snapshot-based restore. Next, I'll go to the RDS automated backup screen and switch to the replicated tag here, or the replicated tab, and look for the cross-region PITR backup and copy the ARN from here. And this ARN will use as the value for the restore. Now keep in mind that when I run this Terraform apply, most of our infrastructure is already created in this region. So this Terraform would not recreate all 15 resources. It will only recreate the RDS database because the PITR configuration forces a replacement for that database. So this process will take some time. I'll pause this video here and I'll turn back on when the DB is fully restored. The Terraform apply completed successfully. and we now have a new RDS DB. But the major change would be in the view lambda function. So let's test this and see what data shows up now in the new DB. Let's scroll down, and we have now 89 rows from region 1. So let me take a screenshot of this and show this side by side with the previous data for a quick comparison. As you can see from these screenshots, the PITR restore actually does more rows than our initial screenshot. And that's because our primary database was still alive for a short time after we captured this first screenshot. So a couple of additional rows were inserted after failure. But the point here is that option 2, or the PITR backup, actually had almost zero data loss. So in summary, the snapshot backups, or the option 1 here, are stored inside the backup vault, and they get all the security and compliance benefit that comes with the backup vault. However, there is a trade-off that the snapshots are point in time. That is, that can lead to a higher data loss depending on the time when the snapshot was taken. PITR cross-region backups, on the other hand, do not live inside the vault. They are outside of the vault, so they don't benefit from those vault protections. However, they can give you an almost zero data loss recovery option in case of a regional disaster because they capture continuous backups or continuous changes. That's it for the video, guys. Hopefully this walkthrough helped you understand the differences and complexities of cross-region backups for RDS. If you found this video helpful, please consider subscribing and leave a comment to the channel if there are any security topics that you would like me to cover.